Hello everyone. In this video I will be talking about definite integrals. So in the last video I had talked about indefinite integrals. Now let us look at definite integrals. There are three questions that have been asked in this exam. So let us look at the first problem. The first problem is integral of x cube sine x dx with upper limit is 0, lower limit 0, upper limit pi by 2. So integral goes from 0 to pi by 2 for x cube sine x dx. So we know that this can be solved by using by parts and then doing by parts again and again and again till we are able to get an expression. However, in one of the last videos I had solved this problem. In is equals to integral of x raised to the power n sine x dx. I had done this problem in the last video. So I'm going to use the result of that video to solve this problem, okay? And it's in the same question paper. So if you have solved this a few minutes ago in that question paper, then you can use that result to solve this problem. It's very good for the students that they have asked a problem in which you can use the results that you have used for a previous problem, okay? So in that video I had solved this integral x raised to the power n sine x. So if in is equals to integral I x raised to the power n sine x dx, then you can write it as minus x raised to the power n cos x plus n x raised to the power n minus 1 sine x minus n into n minus 1 into in minus 2. In our case, x is x raised to the power 3. So n is equals to 3. So I will put n is equals to 3 in this equation. So I3 will be what? X cube sine x dx integral x raised to the power n is 3. So minus x cube cos x plus n is 3. So 3 into x raised to the power 3 minus 1, that is 3x square, and sine x minus n into n minus 1. N is 3. So 3 into 3 minus 1 is 3 times 2, which is equals to 6. So minus x cube cos x plus 3x square sine x minus 6 I1. So how do I compute I1? Just put n equals to 1 in this. So I1 is equals to integral of x sine x dx. Now this is very easy by parts function. X into integral of sine minus differential of x into integral of sine whole integral. Differential of x is 1. Integral of sine is minus cos. Integral of sine is minus cos. So minus x cos x plus cos x, because minus into minus is plus. And integral of cos is what? Sine. So I1 is minus x cos x plus sine x plus c. So what will be I3? I will just put this I1 over here. So I will get I3 is equals to minus x cube cos x plus 3x square sine x plus 6x cos x minus 6x minus 6 sine x plus c. Now the values that are given to us are 0 to pi by 2. So I will put pi by 2 over here and minus and 0 over here. So x at pi by 2 is minus pi by 2 whole cube, but since it's multiplied with cos x and cos pi by 2 is 0, so there it is 0, and sin pi by 2 is 1, so 3 pi by 2 whole square will stay. Again cos pi by 2 0, so this term is 0. Minus 6 into sin x, sin pi by 2 is 1, so minus 6. Now the lower limit, let us look at that one, 0. So there is x over here, x is 0, so this whole term goes to 0, this whole term goes to 0, this term goes to 0. In this there is no x, but sine 0 we know that it is already 0. So this whole thing is 0, and what are we left with? 3 into pi by 2 whole square minus 6. So 3 pi square by 4 minus 6, which is option D. Hence option D is the correct answer. Now second question. Limit n tends to infinity for pi r equals to 1 to n 1 plus r square by n square into 2r by n square. So this function pi is very similar to the function sigma. Instead in function sigma it is plus, right? When you expand the sigma it is plus, but when you expand this function pi, it is product, okay? So what is this equal to? R equals to 1 to n. So 1 plus 1 square by n square whole raised to the power 2 by n square into 1 plus 2 square by n square into 4 by n square into 1 plus 3 square by n square into 6 by n raised to the power 6 by n square into 1 plus 4 square by n square whole raised to the power 8 by n square dot dot dot. So it is a infinite product. It's a series of infinite products. Okay, but we know that integration is summation, but this over here is a multiplication. So my first step in this problem is to somehow convert this product into sum. How do I convert product into sum? One important function that comes to mind is logarithm. We know that log of m into n is equal to log of m plus log of n, right? So over here, if I take log of whole of this, it will change from pi to sigma, right? So let us do that. Let us consider I is equals to limit n tends to infinity pi r is equals to 1 to n for 1 plus r square by n square whole raised to the power 2r by n square. When I take log, what happens to this thing? It get converted to sigma. There you go. Because all of these are products, if I take log of this, so log of a into b into c, what is log of a b c? Log of a b c is equals to log a plus log b plus log c. Okay, since it's an infinite multiplication, log of a b c d e f g h is equals to log of a plus log of b plus log of c plus log of d plus log of e. So that is what has happened over here. Now this is log of 1 plus r square by n square whole raised to the power 2r by n square. We know that log of m raised to the power n is equal to n into log of m. So that is what has happened here. 2r by n square comes down. So log of I is equals to limit sigma r equals to 1 to n into 2r by n square into log 1 plus r square by n square. Now let us assume 1 plus r square by n square is equals to t. When I take the differential, 2r by n square dr is equals to dt. But when n is r is equals to 1, t is equals to what? 1 plus 1 square by n square, and n tends to infinity, so this will become 0. When r is equals to n, this will become 1 plus n square by n square, which is 1 plus 1 is equals to 2. So the upper and lower limit are 1 and 2. Okay, and this whole thing is this is t, so this whole thing will be log t, and this will become dt. So integral of 1 to 2 log t dt. Now we know that integral of log of x is equals to x log x minus x plus c. This is by parts. Okay, we can see the proof over here. Very easy. Log of x dx. I will just multiply 1 here. So integral of uv is equals to what? U into integral of v. Integral of 1 will be what? X minus differential of u. Differential of log x is what? 1 by x. Integral of 1 is what? X. So this is 1 again. So integral of 1 is what? X. So log x minus x. Very easy. So log of I, when I put the limits, 2 log 2 minus 1 log 1 minus 0. Log of 1 is 0. So this will become 2 log 2 minus 2 plus 1. This is 0. Minus 2 plus 1 is minus 1. Now we know that these are all natural logs, that is the base is e. Base is e. So 1 can be written as log of e. Log of I is equals to 2 log 2 minus log e. Again, log of m raised to the power n is n log m. Similarly, n log m is equals to log of m raised to the power n. So this is log of 2 square. 2 square is 4. So log of 4 minus log of e. Again, log of m minus log of n is log of m divided by n. So 4 by e. Take the anti-log on both sides. I is equals to 4 by e. Very easy problem. Option D is the correct one. Now let's look at question number 3. The larger of the two areas in which the circle x square plus y square is equals to 16a square is divided by the parabola y square is equals to 6ax is what? So this is a very standard problem asked in CBSE exam, state board exam every year for 6 marks. Very straightforward problem, very easy problem, but let us see how to do it. So larger of the two areas in which the circle this is divided by the parabola this. So let us just first draw the curves. So this is my circle. X square plus y square is 16a square. 16a square is what? 4a whole square. So 4a whole square. So radius of my circle is 4a. So this distance is 4a. This is 4a. This is 4a. And since x square plus y square, so that is x minus 0 whole square plus y minus 0 whole square, I know that origin is the center of this circle. Similarly, y square is equals to 6ax. This is the kind of curve for y square is equals to 6ax. Now you should know where these 2 points will intersect. X square plus y square is 16a square and y square is 6ax. So I'll just put y square is equals to 6ax into this. 6ax is equals to 16a square. You can solve this. X square plus 6ax. You can write 6ax as 8ax minus 2ax minus 16a square is equal to 0. When you factorize it, what will you get? X plus 8a into x minus 2a is equal to 0. So either the curves intersect at x equals to 2a, which is this point, or which is x equals to minus 8a. X cannot be minus 8a because in that case y square will become negative and you cannot take square root of negative. It will become an imaginary number and we are not dealing with complex numbers in this problem. So these are the 2 points of intersection when x equals to 2a. When x equals to 2a, y square is equals to what? 12a square. So y is 2 root 3a and also minus 2 root 3a, which is this point. Since all of these are very symmetrical about x-axis, we need to know this bigger area, right? He has asked us for the larger of the two areas. So this one is the smaller of the two areas, and this area, this shaded one is the larger, and this one is the smaller. Okay. So first what I will do is I will find out this smaller area and then I will subtract this smaller area from the area of the circle, which is very easy, pi r square. R is what? 4a. So 16a square into pi minus this area, I will get my solution. So how will I compute this area? So the upper portion is equal to the lower portion. The area of the upper and the lower are equal because of symmetry. So I will just calculate this area, this upper portion. And how do I compute that? Integral of 0 to 2a root 6ax. Since y square is equals to 6ax, y is what? Root 6ax. So root 6ax plus from this point to this point 2a to 4a. X goes from 2a to 4a. And what is y? Y is equals to y square is equals to 16a square minus x square. So y is equals to square root of 16a square minus x square dx. So this is the smaller area because this is very symmetrical to this. So the smaller area will be twice of this thing, which I have shown over here by this 2. The bigger area B will be equal to area of the circle minus A. Area of circle is what? Pi r square. R is what? 4a. So pi into 4a whole square minus A, and A is given by this. It is a very straightforward problem. Should be very easy to solve. Okay, so B is equals to 16 pi a square minus A. What is A? A is equals to 2 times integral of 0 to 2a square root of 6ax dx plus integral of 2a to 4a integral of 16a square minus x square dx. This is very straightforward, x raised to the power half. So just increase the power by 1 and divide by the new power. So x raised to the power 3 by 2 divided by 3 by 2 minus, so next plus integral of 2a to 4a 16a square minus x square. This can be done by using x equals to 4a sine theta or 4a cos theta. Whatever you may want to do, it's completely dependent on you. I have done over here as 4a sine y. So 16a square minus x square will be what? 16a square cos square y. So whole square root will be what? 4a cos y. Since x equals to 4a sine y, when I take the differential, I will get dx is equals to 4a cos y dy. Right? Yeah. So I'll put all these values in here and I will try to solve this integral. Also, since I am doing substitution, the value of the upper and the lower limit will also change. When x equals to 2a, what will be sin y? Sin y will be half. That is y is equals to what? 60 degrees or pi by 6. When x equals to 4a, so 4a equal to 4a sine y. What is sine y? Sine y is 1. That means y is equals to 90 degree or pi by 2. We will also have to change the limits because we are substituting the variables. So let us look at how my a will change. 16a square cos square y into 4a cos y dy, pi by 6 to pi by 2. Now 16a square root will be 4a. So 4a into 4a is what? 16a square. Square root of cos square will be what? Cos. Cos into cos is what? Cos square. Okay. So 16a square, also 2 is also there. So this will become 32a square. And this over here I have just substituted the upper and the lower limit. Since the lower limit is x equals to 0, this whole thing will become 0 and only this will remain. Okay, so this will be 16 root 3 by 3 a square. Because this power 3 by 2 is there, when you put in 2a, it will become 2a raised to the power 3 by 2. So 2 into square root of 2. And 1 square root of 2 from here. So this will become 4. 4 into 2 is 8. 8 by 3 and root 3 will remain. 8 by 3 into 2 from here will become 16. Okay. So 16 root 3 by 3. So this is sorted. This will be 32a square. Pi by 2 to pi by 6 to pi by 2. 1 plus cos 2y by 2 dy. How do I get 1 plus cos 2y by 2? Because cos square theta, because cos 2 theta is equal to 2 cos square theta minus 1. So cos square theta is what? You take this one over here, cos 2 theta plus 1 divided by 2, which I have done over here, right? So integral of 1 plus cos 2y by 2 dy. Integral of dy will be just y, okay, which is here. What will be the integral of cos 2y? Sin 2y divided by 2, which is over here. Now just put in the upper and the lower limits, pi by 2 and pi by 6, and this is all just calculations. So a is equals to 16 pi by 3 a square plus 4 root 3 by 3 a square. What will be the bigger area? I have shown over here. B is equals to 16 pi a square minus a. Just put in the value of a. You will get b is equals to 32 pi by 3 a square minus 4 root 3 by 3 a square, which means when I take 4a square by 3 common, 8 pi minus root 3. So which is option A. So we are done with definite integrals. Now in the next video I will cover differential equations. Thank you everyone.